Hey guys, welcome again to another exciting time in the Maths Club. Continuing with our series on indices, we are going to be looking at examples highlighting the 7 laws of indices. So without further ado, let's get started. So this is a reminder of the 7 laws that we discussed about in the previous video. And we said something finally, that the laws of indices are true for all values of A and B, and X is not equal to 0. Right, so all of these things hold given this condition. So let's go. Let's look at the first example. So the first example says that we should simplify 10 raised to the power 2 times 10 raised to the power of 3. We know from the law, I think that is law 1, that whenever we have the same base multiplying each other, we can just add their powers. So that is like 10 raised to the power of 2 plus 3, right? And that's 10 raised to the power of 5. Right. Great. Example 2 says 22n7 divided by 2n3. So first things first is that we can divide the 2 by 22. That will give us 11. 2 here 1, 2 here 11, right? So we have 11 n raised to the power of 7 divided by n raised to the power of 3. Whenever we have something like this, like I can write this like 11 n raised to the power of 7 divided by n raised to the power of 3. Whenever we have something like this, right, I could just say 11 n raised to the power of 7 minus 3, right? And that's 11 n raised to the power of 4, right? So that's basically it for this particular question. Let's see our answer. Great. Now, the third example is saying 19 raised to the power of 0. Remember, what we said, anything raised to the power of 0 is 1, right? I think that's law 3 or law 4, right? And we proved it in the previous video. So our answer here should be 1. Now, this next example is saying z raised to the power of 3 in brackets raised to the power of 5. So according to law, I think this is law 5, right? I think this is law 5, right? So we say whenever we have something like this, we can just multiply the powers. So that would be z3 times 5, right? And that's z raised to the power of 15. So z raised to the power of 15, great. So the same thing too for this. We have a cubed b raised to the power of 4. So it's like saying multiplying this 4 times, right? So we can just multiply each of the powers by 4. So this is a raised to the power of 3 times 4. Then b raised to the power of, you can say, oh, b does not have a power, but 5 is the same as 5 raised to the power of 1, right? So this b has a power of 1. So b1 times 4, right? And I'll give you a12 b4. Right. You can also expand it and say a raised to the power of 3b times a raised to the power of 3b times a raised to the power of 3b times a raised to the power. You see that you still end up with this. So this is a12b4. So this question says 2 number 1 over 4 raised to the power of 1 over 2. Let's solve it. To solve this problem, first thing is that we have to convert all of this to improper fraction. So that is 4 times 2, which is 8 plus 1, which is 9. So that is 9 over 4 raised to the power of 2 times 1, which is 2 plus 1, which is 3, 3 over 2. From what we've done in indices, I could say this is 9 over 4 raised to the power of 1 over 2 multiplied by 3. That means I could say 9 over 4 raised to the power of 1 over 2 and all of this cubed. So we need to find the square root of the 9 over 4. So square root of 9 over 4 all cubed. Right, so one thing that I need to say here is minus 2 times minus 2 will give me 4, right? And 2 times 2 will also give me 4. So whenever you're finding the root of a number, and that root is a positive root, so say in example, we have the square root, right? Let's say we have the 4th root. I always know that there will always be a positive and a negative scenario. Right, it's not always going to be positive, but if it was like cube roots, so if I say cube root of 8, right, I can say 2 times 2 times 2, this will give me 8. But if I say minus 2 times minus 2 times minus 2, minus 2 times minus 2 is 4, 4 times minus 2 is minus 8. This will not give me the same value, right? So this plus or negative values, they only apply when you're dealing with even numbers like square roots, 4th roots, 6th roots, right, 8th roots. So just note that. So if you want to find the square root of 9 over 4, 9, I can find the square root of 9 and I can find the square root of 4. Right, so because I can find the square root of 9, I can find the square root of 4, I can take the direct square roots. So this is like saying plus or minus what? 3 over 2, all cubed. So you must always take note of the positive and negative sign whenever you're doing the square root. If I want to now find the cube of this is like saying plus or minus 3 cubed all over 2 cubed. Right, because if you do this, say plus or minus 3 over 2, plus or minus 3 over 2, plus or minus, you still have the same thing. So this is equal to plus or minus 3 cubed is 27 and 2 cubed is 8. 3 cubed is 27 and 2 cubed is 8. Let's see our answer. The left is in mixed numbers. Let's do that. So 8 divided by 27 is 3 with a remainder of 3. So that's 3 over 8. So plus or minus 3 over 8. That's the solution to this particular question. Let's look at this next question. It says 75a squared b raised to the power of minus 2 all over 5a cubed b raised to the power of minus 3. Okay, so first things first is that we can reduce the 75 over 5. So this 5 here 1, 5 here 1, we'll carry over 2, 5 and 25 is 15, right? So we have 15. A, now this is a squared, this is a cubed. So because it's division, so that will be 2 minus 3. Then b, we have division between, so minus 2 minus 3. Right, so that's 15. A raised to the power of 2 minus 3 is minus 1. B raised to the power of minus 2 plus 3. Minus times minus is plus. So this is 15. A raised to the power of minus 1. B raised to the power of minus 2 plus 3 is 1. So at the end of the day, you can leave it like that. You can say 15b all over a. Remember we said a raised to the power of minus 1 is something as 1 over a. So anyway the answer leaves it, we are covered. So this 15b all over a. Great. So this question says that we should find the square roots of 72 a raised to the power of 3 b raised to the power of minus 2 all over 2a raised to the power of 5 b raised to the power of minus 6. To solve this problem, let's take care of the 72 divided by 2 first. So that will be square root of 36. I could say a raised to the power of 3 minus 5 because a cube over a raised to the power of 5. So I could say minus. Right, then b raised to the power of minus 2 minus 6. Right, because this is b raised to the power of minus 2 divided by b raised to the power of minus 6. So I could say square root of 36. A 3 minus 5 is minus 2. B minus 2 minus times minus is plus, so plus 6. Right, so I could now say square root of what? 36. A raised to the power of minus 2. B raised to the power of minus 2 plus 6 is 4. Great. Now, look at something. I could say square root of 6 squared. A raised to the power of minus 2. B raised to the power of 4. Right. So, from what you said, whenever we have a square root of anything, we need to consider the plus and minus equivalent. So that will be plus or minus. If I find the square root of 6 squared, that will leave me with 6. If I find the square root of a raised to the power of minus 2, that will give me a raised to the power of minus 1. If I find the value of b raised to the power of 4, that will give me b squared. Right, so you might notice something. When you have the square root, just divide the powers, right, by 2. So if I want to simplify this, we said anything raised to the power of minus 1 is 1 over that thing. So this will be plus or minus 6. There's no minus 2 here, so this is 6b squared all over a. Right, so the a will come down because of the minus 1. In case this particular thing, how it became minus 1 is a bit strange, let me just do a bit more modification. So just by the side, you could have said 6 squared, a raised to the power of minus 2, b raised to the power of 4, raised to the power of 1 over 2, from the laws of indices. There is 2 here, there's 2 here, there's 2 here, come on, so I could factor out the 2. So this is 6, a raised to the power, if I remove 2 from this, give me minus 1. If I remove 2 from this, give me 2. Raised to the power of 2 times 1 over 2. Right, of course, you need to note our plus or minus if we're doing this. So if I cancel out 2 from this 2, you can say I have only 1 left. So that's where we had this plus or minus 6 a raised to the power minus 1 b squared. So our answer is 6b squared all over a. Let's check our answer. 6b squared all over a. So that's the solution for this particular question. Now this question is saying if 9 raised to the power of 2x minus 3 all over 3 raised to the power of x plus 3 is equal to 1, find x. So first things first, let's cross multiply. 9 raised to the power of 2x minus 3 is equal to 3x plus 3. So one thing that we know is that this my 9, I can equate it to 3 squared, because 3 squared is equal to 9. So if I break it, I could say 3 squared, open brackets, 2x minus 3 is equal to 3 raised to the power of x plus 3. Right? We know that already. And I could furthermore say and say 2 times 2x is 4x. 2 times minus 3 is minus 6 is equal to 3x plus 3. Now, when things like this happen, they have the same base and they are equating each other. That means that at the end of the day, for them to be equal, look at something. If I say 3 is equal to 3, that's because 3 to the power 1, both of them have the same powers. If I say 3 squared is equal to 3 squared, I can say 2 is equal to 2 because both of them will have the same powers. They must have the same powers for them to be equal. I can't say 3 squared is equal to 3 raised to the power of 3. That is not possible. It's not equal to. So you can see they have different squares. So for these two guys to actually be equal, that means that they must have the same power. So we could say 4x minus 6 is equal to x plus 3. Since they are equal, they must have the same power. We can collect terms and say 4x minus x is equal to 3 plus 6. 4x minus x, that's 3x. 3 plus 6, that is 9. So if I divide both sides by 3, if I divide this by 3, I divide it by 3. So this will cancel this. 3 will cancel 3, this 3. So x is equal to 3. So our x will be equal to 3. Great. And the final question says, if 3 raised to the power of 1 minus n all over 9 raised to the power minus 2n is equal to 1 over 9, find n. Great. So one thing that we can first do is that let's first simplify all of them in terms of 3, right? So this is all over 9 is 3 squared. So 3 squared raised to the power of minus 2n is equal to 1 over 9 is like same thing as saying 9 raised to the power of minus 1, Abi? And 9 is 3 squared. So 3 squared raised to the power of minus 1, right? Let's simplify everything first. So we have 3 raised to the power of 1 minus n all over 3 raised to the power of 2 times minus 2n is minus 4n is equal to 3 raised to the power of 2 times minus 1 is minus 2. Great. So now we can use our laws of indices because this is 3, this 3, they have the same base, right? So we can subtract the power. So this is 3 raised to the power of 1 minus n minus 4n. Remember, this one has a minus, so you have to be very, very careful. Is equal to 3 raised to the power of minus 2. So let's resolve this top. 3 raised to the power of 1 minus n plus 4n is equal to 3 raised to the power of minus 2, right? So like I said, based on that, because if they are equal, that means the powers must be equal, right? I know I could still resolve this. Let me resolve this for that first. So 3 raised to the power saying 1 minus n plus 4n is plus 3n is equal to 3 raised to the power of minus 2. So let's equate the powers. So 1 plus 3n will be equal to minus 2. Collecting like terms, 3n will be equal to minus 2 minus 1. So 3n will be equal to minus 3. If I divide both sides by 3, 3 will cancel 3. 3 will cancel 3 here, 1, 3 here, 1. So my n will be equal to minus 1. So this is our n for this particular question. Great. And with this, we'll be able to apply the laws of indices in different forms, some in combination and some in isolation, right? In the next video, we're going to be talking about standard form. See you guys there.